I'm very excited to talk to you about Koalas, which is one of the new projects that we launched here at Databricks. And so I'm the co-creator of this project. I recently moved to Amsterdam about 6 months ago. Before that, I used to work, well, I've been working at Databricks for more than 5 years, and mostly on the machine learning side. So on the MLlib, graph frames, and a number of deep learning projects. And before that, I was doing a PhD at UC Berkeley. So today's talk is mostly going to be on data science and data engineering, mostly data science, just to make sure that I'm talking I'm making sure that I know who I'm talking about. Who here has used Koala, not Koalas, but Pandas? Okay, so I think you will know what I'm talking about here then. So mostly what I want to tell you about here is why we created this project and how we think Koalas can really help you bridge the gap between small data and big data, and make sure that when you develop something, you can do it with the confidence that your data science project will scale at pretty much any scale, even if you start with small data. So if you look, and if you look at the typical journey of a data scientist, and this is probably how a number of you started, you started to learn on how to do data science using Pandas, and probably on the majority of your time, you analyze data sets which are small enough to fit using Pandas. But then when the time comes to move to larger data sets, this is when you find that there are some restrictions, and typically this involves switching to another tool, for example, Spark, and using the Diaphragm API of Spark. So Pandas was created roughly in around the same time as Spark, and everybody here has been using it, and there is a good reason for that. It is really the standard for doing data science using Pandas, using Python, and also it is a very versatile tool. So you can really use it for doing time series analysis, handling missing data, and so on. Spark, if you were around today, you probably heard a lot about Spark. It was created about at the same time, and it is the way it differs, I would say, from Pandas, is that it was built straight on for dealing with large data sets, and also it has focused a lot on the ETL use case. So, and in this case, it requires a lot of handling of data for doing ETL, and for that means using SQL or doing, for example, streaming and machine learning in the end. And it supports also the Python ecosystem through its PySpark interface, but it aims really at trying to bridge the gap between multiple paradigms. So this is why the main interface probably in Scala, but it also has R and SQL. And because of these reasons, even if the two projects talk about data frames, they talk about the same, they talk about expressing data in this tabular format, there are some subtle differences between the two. It's simply through their history and through what they want to accomplish. So, for example, if you want to access some data, in both cases this is going to be the same syntax, but one fundamental difference between the two is that Pandas comes really from the roots of numerical analysis and allows you to directly modify the data in place for the sake of efficiency. While Spark comes more from the root of expressing large-scale transformations against your data set, and assume that all the transformation you do are immutable. It will not express operations that mutate or change directly the data in a data frame. Which means that after that, a lot of operations, even though they're expressed within their own ways in some natural ways, have a fairly different syntax. And also the Pandas API has focused on very specific use cases that the Spark and PySpark API want to reflect more in terms of SQL operations. Which is why, for example, if you want to count the values of a column, you end up having something which is much longer to express as a Spark data frame operation. And if you want to look at a longer example, you also see that Spark and PySpark can be longer to express, simply because PySpark by default gives you more choices and expects you to deal with more choices. This is very clear, for example, if you want to read some data from a CSV file, Pandas straight on goes for some specific defaults, which correspond to what the user naturally expects, while Spark will give you the full power at the cost, of course, of more verbosity here. So this is why we created Koalas. We started on this project about a year ago, and we announced it at the previous Spark Summit in April. So Koalas is a pure Python library. You can simply install it like you would do with Pandas or any other Python package, and it really aims at providing a bridge between these two paradigms. So in that sense, it gives you the familiar interface of Pandas on top of Spark, and it also gives you the ability to take all the advantages of Spark and run them on top of on top of some code that you have written already for Pandas. So this project has been very quickly getting traction. I think at this point we are pretty much at 11,000 daily downloads, and we have more than 20 contributors coming outside of Databricks. So there's definitely a large ecosystem forming around that. And to show you how easy it is to use Koalas, you simply import it as you would for Pandas, and then you have to replace the import that you do when you want to read a CSV file with Pandas. You simply have to specify a different package, the Koalas package, and it will build for you a data frame, which is distributed and lazy under the hood, which will be distributed. And then you can do the operation that you would expect from Pandas. For example, here, you can rename them columns. You can create new columns on this data frame against some existing ones, and so on. So, of course, behind the scenes, how it works is pretty different. Because everything under the hood, when you use Koalas, will be translated as Spark operations. This is not, so even though it has the Pandas syntax, behind the scene, it will be running Spark operations. And Spark is more lazy by nature, in the sense that in Spark, most of the operation you do in terms of transformation of the data, for example, will not be computed immediately, but will wait until some actions, such as writing a file or displaying some part of the data frame, will have to be done. So in that sense, Spark will, and you'll see that in some of the examples. Spark will wait until you have to really, you really have to commit to something. You have to really do an operation against your data frame for doing it, which means that an operation such as adding a column, for example, is nearly free when you when you do it, when you express it, but it will happen lazily under the hood it will happen lazily afterwards, when you actually have to compute these values, and when you want to display them or to write them onto a file, for example. Another big difference, which we'll see in the examples, is that Spark does not have any intrinsic notion of a row order, and when you use Spark, Spark will treat all your rows as a bag of row object. And well, if you look at Pandas really come from numerical roots, and everything in Pandas is an array. So everything in Pandas has a natural ordering, and you can see that by the default index that is provided against the data frame in Pandas. So Koalas provides some ways to bridge this gap here, and I'll show you what it looks like in practice. And of course, the biggest difference from the user's perspective is what happens when you deal with large files, for example. Spark will be able to seamlessly use all your resources, while Pandas may be a bit more constrained on that and will not accommodate large files, for example. So, of course, the Pandas API is very large. How far are we into covering it? At this point, we have about 60% of the data frame and series API. We have actually had, this is from 2 weeks ago, now we have about 70% of the data frame group by and series API. And a lot of the functions are still missing on the index API, mostly because these functions tend to be very specialized, and we're looking at how to add them. On top of that, we have added a number of functions that are very common when you want to do a manipulation of data with Pandas, such as converting strings to datetime, building get dummies, which is a way to do one-hot encoding using Pandas, and so on. Also, a couple of features which are really exciting, I find, that we added recently are the plotting functions. So that means I will show you a couple of examples. You can take some data set which are pretty large and that are working and coming from Spark, and you can simply call the plotting function just like you would against a Pandas data frame. And one of the key advantages, I would say, of using something like Spark is that it comes with a lot of different plugins for input and output. And of course, Koalas can support that. In particular, that means Koalas can will allow you to read and write some data sets and some formats, which Pandas natively does not support. And also, we are adding a lot of new operations here for supporting multi-indexed columns. I'll show you what it looks like in practice later. Okay, so just to give you a quick idea about what it looks like. So here I have a Databricks notebook. And so here, this is just your regular notebook. You could run all of that inside a Jupyter notebook locally on your laptop. This is not, there's nothing specific here to Databricks in what I'm going to show. So if you start from a notebook, you will typically have already a Spark session in it if you're using PySpark. And if I want to use Koalas, all I need to do is to import this library here, which I have already installed against my cluster here. So I already did if you want to pip install Koalas against my cluster, so this library is already loaded. So Koalas really support most of the operations that you would expect to create some data. For example, here you can use exactly the same syntax as if you would want to build a Pandas series, and it will build for you a series that looks pretty much like what you would expect. And you'll notice here that the ordering of the data is not from 0 to 5. It is in this seemingly shuffled order. This comes from the fact that the data under the hood has been parallelized by Spark, and then when you display it, it will come in a random order. You can do the same thing as well for data frames. So this is exactly the same syntax as you would expect from Pandas. But here, I am creating a Koalas data frame, not a Pandas or not a Spark one. And when I want to display it, it will be running some Spark jobs. So all of this here, and actually just to emphasize this K here, KDF is really here to emphasize that this is a Koalas data frame. You can also some pretty cool operations where you can take some existing objects in your Python environment, and you can pass them inside the SQL statement. So you can make SQL statements very naturally out of everything you have here in your notebook. So here you can take your previous data frame KDF and filter out all the data where the element A here is greater than some value, and this is very convenient if you like SQL, if you come from an ETL background where you do not know all the syntax from Pandas. That's all right. You can mix and match all the pieces you want, either in SQL if it is easier to write in SQL, or you can write it in Pandas if you want to. And then behind the scene, then yeah, this will show here the result. This is what you would expect. All the data filtered out with a greater than 3. And of course, you can take some data coming from Pandas, and you can take a Pandas data frame and then convert it to a Koalas data frame. Behind the scene, this will take your local in-memory Pandas data frame and slice it and then broadcast the pieces to the different executors on your cluster. And of course, you can do that also with Spark data frames. With one additional piece, which is very convenient. When you import the package, the Koalas package, it will automatically change Spark so that this toKoalas method is available onto your Spark data frames. So this allows you to go back and forth from a Spark data frame to a Koalas data frame and vice versa if you need to. So that means if some operations are easy, or if you have a piece of code which you expressed for Pandas within a larger Spark workflow, you can directly inject these parts related to Pandas and then go back to a Spark data frame if you want to. Yes?
This does not read as data copy, right? So if I do two Koalas, there will be a new copy of the...
So the question was, if I do a copy here, if you call two Koalas onto a Spark data frame, will the data be copied? Not at all. Under the hood, what it will do is that it will create a new Koalas data frame object around the Spark data frame, add more information. We'll see what kind of information it adds, and then propagate that. And when you do the operation, the opposite operation to Spark, it simply exposes the underlying Spark data frame. Yeah, so this part, okay, here took 2 seconds because it needed to display it, but going from two Koalas to Spark and so on, this is completely free from a programming perspective. The part about transforming it from a Pandas data frame, though, requires some data copy because the two runtimes are different. And of course, this data frame has an index, just like you would expect from a Pandas data frame. This object here is actually an object that comes from the Koalas world. Same thing here for the columns, and just like you would just like you would be able to do for the Pandas data frame, you can export it as an NumPy array. This operation is expensive, and there are some warnings if you try to export too much data, because then you can run out of memory. So I'm not going to go through all the operations that you can do, but pretty much at this point, that just like you would do with a regular Pandas data frame, you have access to all the basic functions. So, means you can do describe, which is very convenient if you have a Spark data frame. That means you can take a Spark data frame, convert it to Koalas, calling describe, and you get all the statistics that you have typically from Pandas, and so on. A couple of cool things, in my opinion, are the same syntax for doing grouping, which can be much more convenient sometimes than finding the equivalent for Spark. And of course, as I was mentioning, the plotting. So, by the way, on the plotting, you will see that you can use a cumulative sum, which is using window functions in a distributed fashion under the hood. So this is using really all the power of Spark to parallelize the Pandas API here. And just like you would expect, here is when you call plots on the Koala series, it will run a couple of Spark jobs to display to give you a plot here. So just to quickly go on some of the data sets on the I/O part. So the Parquet is one of the file formats which is the most efficient and is well understood by both Spark and Pandas. And the big difference here is that when you call toParquet or readParquet, it will use Spark's built-in facility to read and write Parquet, which means that it will be able to read distributed Parquet files, not only just one Parquet file, but distributed Parquet files. And also when it writes it, it will by default write it into multiple chunks coming from the different writers. So that's one of the small twists that you have when you want to export data. And of course, because this is using Spark under the hood, if you're using some files, some other file formats, such as the ORC format, which is pretty common if you're coming from the Hive world or the Pig world, then you can directly call this toSpark IO function, which will call under the hood all the facilities from Spark to read and write this file format. So, and I've seen a couple of people actually taking their Pandas data frame, converting it to Koalas, and then using that as a writer because it was simpler for them to install it in their environment because they already had both of them. Okay. So after saying that, okay, you are probably going to ask me what works and what doesn't, and if it is actually working the way it should. So we had So we worked with one customer to make sure that they would be able to take their Pandas code base, which they were struggling to scale out, and to make sure that Koalas would be able to work with them. So their experience was that for what they were doing, which was pretty simple UDF applications and groupings, and applying their own custom functions on chunks of the data, they were able to get a massive speed up compared to Pandas. So the blue line is the runtime in Pandas, and the red line is the Koalas runtime. And they were able to use the same code base, both for Pandas and Koalas, while doing some very limited code change. So I think they talked about less than 1%, which here was, from what I remember, 180 lines of code change compared to everything that they had. So this is an example. So I think this shows you that it is possible to do data science at both small scale and large scale without having to endure the pain of trying to scale out your computations. So just to quickly explain to you how it works under the hood, I want to explain here a little bit of the technical details, so that you know what to expect when you see some operations that seem to be slow compared to and some operations that are much faster. So the way we're able to replicate the Pandas data frame API is by having essentially two interfaces. One internal interface, which is immutable, so which corresponds to the same model as Spark, where you create a new internal frame for all the operation you do on that, and a higher level public API, which support all the seemingly looking mutating operations. And this higher level API simply registers all the operation that it needs to do before executing them. So what I mean by that is that the internal frame will refer to the names and, for example, which columns are indices inside your data frame, and then it will hold the Spark data frame. And when you do some API calls, then you will get typically a new Koalas data frame, which will also create a new internal frame. What may happen, for example, when you set the index, is that it only updates the internal metadata. So it doesn't even create a new Spark data frame. It simply changes the name mapping internally without even doing any operation on the Spark side. Some other operations, when you do operations that are in place in the Pandas world, will create a new internal frame, and this frame will contain the new state and will refer to a new Spark data frame. This is how we can support all the API from Pandas that has in-place operations, seemingly. All these in-place operations are actually copied and mimicked in a way that is immutable under the hood. There are some differences due to performance, and this is typically due to how Pandas is very flexible into how you can combine the data in its API. So for example, if we take two series coming from the same data frame, and we add it to the same data frame, this is totally good to go in Pandas, and also in Koalas and Spark. If we try to have them coming from different data frames, then Pandas will allow it, and it is for now forbidden to do by default inside Koalas. So the reason for that is that if you look at the equivalent Spark code, so in the case of on the left hand side, then adding a new column corresponds with 2 other columns coming from the same data frame. Is simply appending a new column, and this is a select statement. If you try to do the same thing with Spark, with columns coming from different data frame, you will get an analysis exception telling you that this is a forbidden operation, because Spark cannot easily parallelize this operation. What you need to do is mention that to Spark that there is an index and Spark that will need to do a join operation on the index, and this operation can be very expensive. Because it will require potentially a full shuffle of your 2 data frames across your cluster. This is why we allow this syntax if you set a specific option to allow that. So this is here a trade-off that you as a developer can do. By default, Koalas here will be conservative and will prevent you from running this operation. But if you really want to try something quickly, at the potential cost, potentially some computing cost, you can do that immediately by turning on this flag. And as I was mentioning, another problem that we have when converting between the 2 is that in the Pandas world, everything is indexed. In Spark, because there is no ordering, we need to somehow to add this notion of index. And there are multiple, so I don't want to go here into too many details, but as you have seen before in the example, you can end up with rows in different orders based on how Spark decides to parallelize your data. And Spark, so here we offer multiple modes of building this index. So one of them is very fast, but will not have some nice guarantee of contiguous values for the. Some others will be much slower, but then have more guarantees. So I invite you to look at the documentation if this is a problem that you're having when switching your code from Pandas to Spark to Koalas here. Okay, so what you did expect in the incoming month, we really want to have as much coverage as we can of the API. One of the big pieces that is missing right now is the support for categorical data types. So right now, this is a very specific type inside Pandas. It is not supported, but we are looking at how we can add it on Koalas without having to change the Spark interface for doing that. Also, there has been a lot of demand for more time series functions, so we will do that. And maybe you didn't see it too much, but in the graphs about the performance from this this example here, Virgin Hyperloop, there is a little bit of an overhead at the Koalas layer, and we're trying to remove it as much as possible. In particular, when we know that there is a small data frame, we're looking at how we can directly invoke Pandas to do operation on small data frames, so that you do not pay the costs and the overhead of running Spark, even for small data. So then we want to do the switch automatically for you, so that if you want to, you can decide that you can use the local machine for small data, and then it will scale out on the cluster if it needs to. So if you want to try it out, this is published on pip and the Conda Forge. So you can simply do pip install pip install Koalas, Conda install Koalas, and the doc also contains some tutorial if you want to try it out. Okay, and of course, this is really a potentially ambitious project in scope, and we need to prioritize what we're implementing here. So if you have some requests about some APIs that you really want to see supported, or for which you have a need, then we would love to hear from you for that. And if you want to contribute, a lot of the functions are really taking a Pandas function, looking at what the equivalent would be in the Spark world. Typically, it is a 1 or 2 line functions, and then submitting a pull request with a test for that. Okay, so this is what I wanted to cover. Thanks a lot, Code Data Driven here for hosting us. And I'll be happy to take a few questions, I guess. Yep. We still have time for that, yeah.